could this possibly be a projection matrix? Well, sure. And then we could just check, well, let's take something that's in the space that it's supposed to project onto. For example, is the vector 1, 1, 1 supposed to be in the space that it projects onto? Yeah. Yes, it is. And we could calculate p times that vector. It's going to be like a miracle. You ready for this? Now, you already know, like, theoretically, you know what's going to happen. I'm going to do p times the vector 1, 1, 1, and what is the result going to be? 1, 1, 1, because it shouldn't change a thing. It's already in the space, right? Shouldn't move it. So let's take our p, 1, 1, 0, 1, 1, 0, 0, 0, 2, 1/2, multiply by the vector 1, 1, 1, and I get 2, 2, 2 times 1/2, which is 1, 1, 1. Okay? Feel free, exercise left to the reader. Check, make sure that when you do p times this or p times that, you get back those vectors as well. Oh, somebody has been doing that on their homework and exit tickets. Exercise left to the reader or something along those lines. You do not have license or privilege to do so. That is something only pretentious, mean, and hypocritical math professors can pull. Okay, so as a student, you've not yet earned the right to be pretentious, mean, or hypocritical. So no more exercise left to the reader. And I don't know, it could be several students. I know that both Mindy and Tyler have mentioned it. For all I know, it's one dude and I'm getting mad at all you over it, or one gal, or one of the other 51 genders recognized by the state of California. Yeah. They're all known to the state of California. Okay, so hey, how about we get to something that might actually help you on your exit ticket today? Okay, we need to start talking about orthonormal vectors. So let's break this down. This breaks down into two words that you should already be familiar with. So the first kind of, this is a compound word, right? Ortho should not make you think of an orthodontist. It should make you think of the math word orthogonal, which is just the bombastic way of saying perpendicular, okay? Now, normal, you should have encountered that word in Calc 2. What is a normal vector? Well, it can have a couple different meanings, right? Sometimes you talk about a normal vector as being like perpendicular to a surface. Other times you maybe talked about a normal vector being of length 1. Okay, so yeah. Here we're referring to unit vector, length 1. So if I have a set of orthonormal vectors, what am I saying? Looks to me like I've got two properties I got to verify, right? So we're going to take a set, and orthonormal vectors we normally denote, instead of with V's, we denote with Q's, right? So, and that's just a, what's the right word for that? It's not a convention because it's not like expected, but it's tradition. Yeah, there we go. It's tradition that when you're talking about orthonormal vectors, you denote them with Q's. Yeah, because Q's are clearly normal. So, so here's a set of orthonormal vectors. What do we need to know that these are orthonormal? We need to know that Qi dotted with Q, whoa, that's not a Q. The next thing on my mouth was going to be J. Qj should be 0. Why? Because I want these vectors to all be orthogonal. Right? How do you know if two vectors are orthogonal? Their dot product is 0. So Qi with Qj is 0 whenever I is not equal to j, right? Now on the other hand, what is Qi transpose Qi? Should be 1 because you do the dot product of a vector with itself and you get its magnitude squared, but if its magnitude is 1, 1 squared is 1. So that's really what we got going on here. Whenever we have a set of orthonormal vectors, they will have these two properties. Okay. Now, have I gotten mad about how we name things in mathematics yet? A couple times? I'm about to do it again. Mathematicians, like, I mean, maybe not with you guys, right? Because you're in linear algebra, which means you're taking more mathematics than you would be forced to get most college degrees, right? You've elected into extra mathematics by nature of whatever major you chose. But I think if you survey your friends and say, oh, I'm in linear algebra, they're like, oh, I hate algebra, math's hard, right? Like, that'll be the average response. For example, I went to parent-teacher conferences. You know, my son was in first grade last year. I went to parent-teacher conference. Oh, Blake tells me that you teach math up at the university. Yeah. First thing out of her mouth, oh, I hate math. Right in front of my son. Math from her, right? So, anyway, there's a societal like hatred of math, and it's you're like an outlier if you say no, I like math, right? I like to learn things. So I think mathematicians, we make things harder on ourselves by naming things very poorly, because then someone comes along and says, well, that doesn't make sense, right? Because they read a name that's misleading. Maybe they're understanding to a point, and then all of a sudden they get to, oh, an imaginary number. Well, it's imaginary, why should I worry? It's imaginary, it's make-believe, right? That's an example of a poorly named mathematical term. Here's another one. Orthogonal matrix. Okay, I'll tell you what that is in just a second. Now that I've told you the name sucks, I want you to tell me what you think that is. A perpendicular matrix, right? Okay. I'll tell you. What it really refers to is the columns of the matrix having some sort of property. What do you think that property is? They're orthogonal. Doesn't that make sense? And that is incorrect. An orthogonal matrix is a matrix with columns that are orthogonal and normal. So why on earth don't we call it an orthonormal matrix? We don't. We call it an orthogonal matrix just to screw with you. Great. Okay? I make a big deal about that because I need you to remember when we say orthogonal matrix, I could just, pretend like the mathematical world at large doesn't call these things orthogonal matrices, and I could teach it to you as these are orthonormal matrices, right? And I could pull the wool over your eyes. You would never know I was lying to you. And it would avoid confusion, right? And then you leave the class, and then you're screwed, right? You have no idea what broke, okay? So rather, I'm just telling you, I didn't name it. We're going to stick with the name, but I hate it. Okay, so orthogonal matrix is a matrix with ortho normal columns. In other words, if I took my Q1 to Qn and slapped them in as columns of a matrix, that would be a orthogonal matrix, because the columns are orthonormal. Okay, so let's make an observation real quick. Capital Q equal to some orthogonal matrix, Q1, Qn. Okay? And let's just, for the sake of, I don't actually have to tell you this, well, ish. But let me just tell you that Q is a square matrix. Okay. Can you calculate Q transpose Q?
Would that mostly be a matrix full of ones?
Yeah, so that's one thought.
Because
Sometimes we call a matrix full of ones J, right? And so that's your speculation. And so why you're thinking that, because when you do a dot product of one with another, you get one, right?
well, I was thinking because so this, if you consider them like a orthonormal set of vectors, you're basically the Q transpose times Q is basically just dotting each vector with itself. Oh, it'd be identical. Yeah.
Oh, yeah. Mathematics is that way, folks. As you talk about it, you often come to an understanding. So that's why I let you talk. Thank you. Okay, so why is this I? I mean, he got it, and I know he got it because he talked himself into it, right? But let's try to convince those of you that maybe weren't convinced by his argument. Q transpose, what does it look like? It looks like Q1 as a row, right? Q2 as a row, Qn as a row, and then Q, of course, Q1 is a column, Q2 is a column, Qn is a column. Okay, so what's going to happen? Let's think about the dot product method of matrix multiplication. Does that seem fair? So if I want the 1-1 entry, the 1-1 entry, that entry, I have to do row 1 dotted with column 1, right? Q1 dotted Q1 is 1. Now let's take some entry that's not on, let's stay in the first row, but not the 1-1 entry, the 1-5 entry maybe. How would we do the 1-5 entry? We do Q1 dotted with Q5. What is Q1 dotted with Q5? They're orthogonal, so it's 0. In fact, it's orthogonal with everything, so it's 0. Right? The only way you get a 1 is when they're the same. So, how do you know if a matrix is an orthogonal matrix? Q transpose Q is I. I should probably shut up. You should do your exit ticket, and then you should go. Did you make it equal to 2, Jenna? We're through like 3.5.
We just say like it's occupied.
Because of that. Yeah, next time all about
Yeah, it's going on.
This is great. I've gotten into it like 5 minutes back from this week to say.
Yes, exactly. So you do.
Yeah, when you work with both things
No, that's just square root too. It's just square root because the columns have to have unit length.